We are stardust. The very elements that make up our bodies, carbon, oxygen, iron, were born in the hearts of ancient stars, scattered across the universe in spectacular explosions. Every atom in our bodies was forged in the heart of a dying star. We are, quite literally, children of the cosmos, connected to the universe in ways both poetic and profound. To understand ourselves, we must understand the universe, and for that we build tools to extend our senses. Telescopes are our eyes in the dark, reaching farther than we ever could alone. The James Webb Space Telescope is our newest, most powerful eye on the cosmos. It's a marvel of engineering, designed to answer questions we've only dared to ask. It's a golden honeycomb of mirrors, a million miles from Earth, built through international collaboration. Scientists and engineers from around the world joined forces to make this vision a reality. Launched on Christmas Day 2021, JWST sees the universe in infrared, the light of heat, revealing what visible light cannot. It peers into the hidden corners of the cosmos, unveiling mysteries long concealed. Infrared pierces cosmic dust, giving us a front-row seat to the birth of stars and planets. We can now witness the earliest moments of creation, hidden behind veils of interstellar dust. Since 2022, JWST has rewritten textbooks and challenged our assumptions. Its discoveries have sparked new questions and inspired a new generation of explorers. For centuries, we heard only part of the universe's symphony. Our instruments were limited, our vision incomplete. Now JWST lets us hear the full composition, from the birth of stars to echoes of the Big Bang. It connects us to the universe's grand story, from its fiery beginnings to its distant future. It's a time machine, a heat seeker, and a storyteller. With every image, it brings us closer to understanding our place in the cosmos. JWST orbits the Sun at the second Lagrange point, L2, where gravity keeps it stable and far from Earth's heat. This vantage point allows it to gaze undisturbed into the depths of space. Shielded by a 5-layer sunshield, it operates in the freezing cold, detecting faint whispers from the edge of time. Only in this deep chill can it sense the faintest heat from the earliest galaxies. This is where our journey begins, in the cold and the dark, where the secrets of everything are waiting. The unknown beckons, and we are ready to listen. The universe is about to reveal itself as never before. With JWST, we stand at the threshold of discovery, ready to witness wonders beyond imagination. Our solar system is a cosmic shooting gallery, where countless objects race through the vastness of space at incredible speeds. It's filled with asteroids. Most are harmless, drifting quietly in the darkness, but a few come dangerously close to Earth, reminding us of the ever-present risks from above. Planetary defense isn't just science fiction. It's a real, urgent responsibility for our species, demanding vigilance and global cooperation. In late 2024, astronomers detected a new object, 2024 YR4, a faint speck in the night sky with early calculations suggesting a possible collision course for Earth. The projected impact date, December 22, 2032. The world watched as the countdown began, uncertainty hanging in the air. The odds of impact were low, but the uncertainty was high. No one could say for sure what would happen. Scientists from around the globe united, sharing data and expertise to refine the asteroid's path, racing against time to understand the threat. But from Earth, YR4 was just a point of light. Its true size, and thus its potential for destruction, remained a mystery. This is where the James Webb Space Telescope, humanity's most advanced eye in space, was called to action. Designed to look back in time and study the origins of the universe, JWST was now tasked with a new mission, protecting our future. Its mission: measure the faint heat signature from a small, dark rock millions of miles away, using its powerful infrared vision. The fate of this mission, and perhaps our own, rested on Webb's unique abilities to reveal what ordinary telescopes could not. Sometimes the best way to defend our planet is to see the invisible and trust in the ingenuity of science to keep us safe. By early 2025, concern over asteroid 2024 YR4 had reached a fever pitch. Scientists, governments, and the public all watched anxiously as new data emerged. The impact probability rose to 2.3%, an unacceptably high risk for an object of this size, sparking urgent discussions among planetary defense experts. The problem was its size, a mystery ranging anywhere from 40 to 90 meters across. This uncertainty made it nearly impossible to predict the true scale of the threat. That's the difference between a regional disaster and a potential global catastrophe. The stakes could not have been higher. Brightness alone couldn't reveal its true size. The asteroid's reflectivity, or albedo, was unknown, making optical observations insufficient. Astronomers needed to measure its heat, its thermal emission, to estimate its size more accurately and understand its composition. Only the James Webb Space Telescope, with its advanced infrared capabilities, could do this crucial job. Led by Andrew Rivkin, an international team of astronomers raced against time, coordinating across continents and time zones. YR4 was moving away from Earth, growing fainter by the day, and soon would be too dim for ground-based telescopes to track. Spring 2025 was the critical window for observation, a narrow opportunity before the asteroid slipped beyond reach. The world watched as JWST pivoted from exploring the edge of the universe to focusing on a threat in our own cosmic neighborhood. Using its mid-infrared instrument, MIRI, Webb could detect the asteroid's faint heat signature, invisible to any other observatory. By combining this thermal data with optical measurements, astronomers could finally determine the asteroid's true size and refine its orbit with unprecedented accuracy. The mission became a high-stakes celestial investigation, with every second and every pixel of data counting. Would humanity need to prepare for catastrophe, or could we stand down and breathe a collective sigh of relief? The answer depended on the sharpest eye humanity had ever built, a marvel of engineering and hope. Science and survival were about to intersect, the countdown had begun, and the world was watching. The world held its breath, waiting for the answer that would shape our future. In March and May 2025, JWST locked onto 2024 YR4, collecting precious infrared data. No spectacular images, just a stream of numbers, but those numbers held the key to our safety. The analysis was swift. YR4 was smaller and darker than expected, absorbing sunlight and radiating heat. By combining Webb's thermal data with ground-based optical data, scientists pinned down its size and refined its orbit. The result? YR4 would miss Earth by a comfortable margin. The danger had passed. JWST had done its job, not just as a cosmic explorer, but as a planetary guardian. This mission was a landmark for planetary defense, proving the practical value of pure science. We looked into the darkness and found certainty, not fear. JWST's versatility had safeguarded our future. Knowledge, not luck, was our shield. The world exhaled in relief. Sometimes the greatest discoveries are the ones that let us sleep at night. With Earth safe, JWST turned its gaze back to the dawn of time. In December 2024, it discovered a galaxy so ancient and unusual, it challenged our theories, the Firefly Sparkle. This galaxy, just 600 million years after the Big Bang, was revealed in stunning detail thanks to gravitational lensing. Instead of a blur, Webb saw at least 10 brilliant clumps of stars, like fireflies scattered in the dark. Each cluster was a building block, caught in the act of formation. For the first time, we saw a galaxy from this early epoch resolved into its components, a cosmic ultrasound. The Firefly Sparkle became a fossil record of galaxy construction. The Firefly Sparkle provided direct evidence for hierarchical assembly, the theory that galaxies grow by merging smaller pieces. Webb's observations showed companion galaxies nearby, likely interacting and triggering bursts of star formation. We witnessed the messy, dynamic process of galaxy growth in real time. This discovery helped solve a puzzle. Some early galaxies grew fast, but others, like Firefly Sparkle, assembled gradually. By studying these ancient clusters, we glimpsed the first generation of stars, made of hydrogen and helium, seeding the cosmos with elements for life. The Firefly Sparkle is a link in our cosmic ancestry. It's not just a galaxy story, it's ours. The universe builds itself, piece by piece, and we are part of that story. JWST doesn't work alone. It partners with Hubble, its legendary predecessor, to create a fuller picture of the cosmos. Hubble captures sharp details in visible and ultraviolet light. Webb peers through dust in infrared. Together, they reveal the universe's hidden layers, like seeing a portrait in both regular and thermal vision. In July 2025, they released a stunning view of a star cluster duo, each telescope highlighting different features. This synergy revolutionizes astronomy. Hubble maps mature stars, Webb uncovers hidden star nurseries. Their partnership is a metaphor for science, building on what came before, pushing boundaries together. Webb answers questions Hubble raised and raises new mysteries for future telescopes. The quest for knowledge is multi-generational. The universe demands more than one perspective. Together, we see farther. Our solar system is visited by interstellar objects, messengers from other stars. In July 2025, astronomers discovered a new interstellar comet, 3I/Atlas. Webb was quickly turned toward it, seizing a rare chance to study a pristine sample from another star system. As the comet neared the Sun, Webb's spectrographs analyzed its vaporizing ices, revealing its chemical makeup. Comparing 3I/Atlas to other comets helps us understand the diversity of planetary systems and the ingredients for life across the galaxy. JWST transforms fleeting encounters into profound scientific opportunities. As of July 2025, JWST has completed 3 years of science, exceeding all expectations. It's protected our planet, revealed the birth of galaxies, partnered with Hubble, and studied interstellar visitors. These discoveries are threads in the grand cosmic story we all share. Webb shows us the universe is dynamic and interconnected. The same laws that shape galaxies guide asteroids and comets in our own backyard. Science connects us to each other, to our past, and to our future. Webb's images are more than data. They inspire wonder and perspective. The journey is far from over. JWST has fuel for decades. What secrets will it uncover next? The unknown is what makes exploration thrilling. We are explorers on the greatest voyage, understanding our place in the cosmos. The universe is whispering its stories, and now we are finally listening. Our cosmic story is still being written. The next chapter awaits.